Have you ever wondered why an apple falls down from a tree and not up into the sky, or how a rocket can shoot straight into space? Well, a brilliant man named Sir Isaac Newton figured it out. More than 300 years ago, he discovered three special rules, called Newton's laws of motion, that explain how everything in the universe moves, from rolling balls and running cars to flying planes and even the Earth itself. So get ready to explore the forces that make our world move, one law at a time.
Hello, everyone. Today, I'm going to show you a fun and simple experiment that demonstrates Newton's first law of motion, also known as the law of inertia. Let's start with the setup. First, we place a penny on top of an index card, which is balanced over the mouth of a glass. This is our starting point. Now watch closely. With a quick, sharp flick of the finger, we move the card horizontally. What happens next is really interesting. The card flies away, but the penny doesn't follow. Instead, it drops straight down into the glass. Why does that happen? Well, Newton's first law says that an object at rest stays at rest unless acted on by a force. In this case, the penny is at rest. When the card is flicked away quickly, the penny doesn't move with it because of inertia. It resists the change in motion. Since the card moves out from under it, gravity pulls the penny straight down into the glass.
Let's look at an everyday example of Newton's first law of motion. Something you've probably seen many times. A soccer ball. A soccer ball sitting still on the field won't move by itself. It just stays there until a player kicks it. That kick is an external force. Once the ball is rolling, it will keep moving in the same direction unless something stops it. Like friction from the grass, or another player blocking it. This is inertia in action. The ball resists changes to its motion. It won't move without a force, and it won't stop unless another force acts on it. So next,
Newton's second law of motion, the law that connects force, mass, and acceleration. Newton's second law states that the rate of change of momentum of a body is directly proportional to the applied force and happens in the direction of that force. In simpler terms, it means that when we push or pull something, it moves faster or slower, depending on how much force we apply and how heavy the object is.
The second law of motion project, called the Egg Car Crash Challenge. First, the design challenge. We built a small vehicle using everyday materials like cardboard, foam, and rubber bands. Our goal was to protect a raw egg during a crash or impact. Next, the physics exploration. We tested how different forces and levels of acceleration affect the egg during a collision. We tried different designs and cushioning materials to see which one worked best to keep the egg safe. Finally, the learning outcome. Through this experiment, we learned how mass, force, and acceleration influence motion. It also helped us understand how these same ideas are used in real-world safety engineering, like how cars are designed to protect passengers during crashes.
Here comes Newton's third law of motion, also known as the law of action and reaction. It says, for every action there is an equal and opposite reaction. That means whenever you push or pull something, it pushes or pulls you back with the same strength, just in the opposite direction. Forces always come in pairs. One is the action and the other is the reaction. For example, when you push against a wall, the wall pushes back with the same force. Or when you jump off a boat, the boat moves backward while you move forward. So remember, every time you act on something, it acts right back on you. That's the magic of Newton's third law, action and reaction. Hi there, I'm Spidey, your curious little science explorer. Today we're blasting into Newton's third law of motion. It says, for every action there's an equal and opposite reaction. Let me show you how it works. Take a balloon, tape it to a straw, and thread it through a string stretched tight. Now let go of the balloon. Whoosh! The air rushes out one way and the balloon rockets off in the opposite direction. That's Newton's law in action. Simple but powerful. And guess what? This same principle is how real rockets, jets, and even spaceships launch into space. So the next time you see a rocket, just remember it all started with a balloon.
Newton's laws aren't just ideas in a textbook. They're happening all around us, every single day. Let's take a look at how these laws work in the real world. First, automotive safety. When a car suddenly stops, your body wants to keep moving forward. That's inertia from Newton's first law. But airbags and seatbelts apply a controlled force to stop you safely, protecting you from injury. Next, space exploration. Rockets lift off by pushing hot gases downward at high speed. According to Newton's third law, the gases push the rocket upward with an equal and opposite force, and off it goes into space. And finally, sports performance. Athletes use Newton's laws in every move they make. When a swimmer pushes water backward, they move forward. When a basketball player jumps, the ground pushes them upward with equal force. That's Newton's magic in action. So, from cars to rockets to sports, Newton's laws of motion are everywhere, shaping the way our world moves.
Meet Sir Isaac Newton, one of the greatest scientists who ever lived. He was a brilliant thinker from the 17th century who completely changed the way we understand the world. In 1687, he wrote a very famous book called Principia Mathematica, where he explained his 3 laws of motion, the rules that tell us how everything moves. Newton's ideas didn't just stay in books. They became the base for rockets, machines, and even space exploration. Thanks to him, we understand why things fall, move, and stop, and how the universe keeps everything in motion.
Sir Isaac Newton's 3 laws of motion changed the way we understand the universe, and their impact is still felt today. His laws form the foundation of physics, explaining how every object moves, from the tiniest particles to the largest planets in space. These same principles inspire engineering marvels, helping us design safer cars, stronger bridges, towering skyscrapers, and even the rockets that launch satellites into orbit. And Newton's legacy doesn't stop there. Through endless exploration, his ideas guide scientists and explorers as they uncover new secrets of our universe, from planetary motion to the forces that keep galaxies spinning. Every time something moves, a ball rolls, a plane flies, or a planet orbits the sun, it follows the timeless principles Newton discovered over 300 years ago. Truly, his legacy is still in motion.